So today we are going to discuss about Unit 5, Introduction to High Performance Computing. So the topics that we are going to cover today are the goals of parallel computing, the speed or parallelism, the CPU versus high performance computing, the architecture of a modern GPU, and what is GPU computing and what is data parallelism, and different types of parallel programming languages and models that are available. So next we are going to talk about parallel computing. So in the unit 4 we have already discussed about the concepts of parallel processing, where we come across the concept of pipelining technique, which is used in order to achieve the parallelism in a processor. So the same thing, so parallel processing is a the parallel computing is a continuation of parallel processing. So here parallel processing or computing is nothing but it is a technique where multiple streams of calculations or data processing tasks will be done across multiple CPUs that are present in a computer system, or we can also call it as it is a technique which enables the system to achieve simultaneous data processing tasks. And why do we need to perform the simultaneous data processing task is to speed up the performance of your computer system. So overall the parallel computing and parallel processing are interrelated with each other, where the main goal of them is to increase the performance of a computer system by implementing the parallelism across multiple CPUs that are present in the system. So why do we need the concept of parallel computing? What is the need? Why do we go for the concept of parallel computing is the real world applications nowadays, they require very dynamic solutions, and moreover we are dealing with large sets of data. When you take a database applications or any type of multimedia applications where we are going to work on large sets of data, and that data is not possible in a single processor systems or a serial processing environment. So in order to deal with the complex and large data sets and their management, the concept of parallel computing is introduced, and it also provides the concurrency. So when you are executing parallel processing, it is going to save your time as well as your money, and it ensures the utilization of resources. All the resources that are available in the system can be effectively utilized by implementing the concept of parallel computing. So that is the reason why we go for the concept of parallel computing. And if you see this diagram, we have to first identify what is the difference between a serial processing environment and a parallel processing environment. So this diagram will clearly explain you. So if you see here, this is an example of a serial processing where you have a single counter and the machine at the counter, and there is a queue line who are waiting for the service from the person who is available in the counter, and this person, you can consider this counter as a CPU. So when you see this person, he can provide service to one person at a time. So this is a serial processing, one by one only he can provide a service. Coming to a parallel processing environment, so each counter can be considered as two CPUs. So here we have multiple CPUs that are present in the system, and at each CPU you can provide service to one customer at a time. So here parallelly multiple counters you are providing services at the same time in parallel for two persons at a time. So this is a concept of parallel processing and the difference between the serial processing and parallel processing. Next, we will see what is the difference between concurrent processing and parallel processing. There is also one more type of processing apart from serial, which we call as a concurrent processing. So in concurrent processing, if you see, this is an example of a concurrent processing where you have a Coke vending machine and there are multiple customers which are standing on two queues, but the Coke vending machine can provide service to only one customer. It can give only a Coke bottle to one customer at a time. Even though you have multiple queues that are available, the service can be provided by the dispenser only one at a time. So this is called as a concurrent processing. Here one CPU can can provide service to one customer at a time, even though there are multiple instructions or multiple queues available here. When compared to a parallel processing, for each and every line we have a vending machine available where they can provide service to one customer. Each of them can provide service to one customer at a time. So since there are two vending machines available, they can provide service to two customers at the same time. So here we can consider the vending machines as the CPUs. In case of concurrent processing, we have only one CPU, but in case of a parallel processing environment, we have two CPUs available which are capable of providing service to two customers at the same time. So this is the difference between a concurrent processing versus parallel processing. So this is an example of a parallelism in a supermarket checkout queues. So how can you say that the parallelism is being implemented in a supermarket checkout queues? For example, if you say take a simple supermarket where there is only one checkout queue, there will be a long line, and the checkout queue, the person standing at the checkout queue, he can perform a service to only one customer at a time. But this is a example of a supermarket where you have multiple checkout queues available and multiple persons available at the checkout queues to provide service to the customers. Even though there are more number of customers available, they are divided equally among the checkout queues, so that at a time the checkout queues, if you see here, there are 5 checkout points, so they can provide 5 services to 5 customers at the same time, so that the customers will not get exhausted. They can get the service in a less amount of time. So this is an example of parallelism which can be implemented in a supermarket checkout point. Next, if you see this diagram, can you identify what type of computing it is, whether it is a serial computing or a parallel computing or a concurrent computing? So if you see here, a person at a time, he is trying to wash his clothes and he is looking after his mobile, he is doing some work on his mobile. So at the same time, if you consider this person as a CPU, he is doing multiple tasks at the same time. So we call this as a parallel computing environment. This is an example of a parallel computing. So what are the goals of parallel computing? So by implementing parallelism in the system, there are different goals that can be achieved. The first goal is a fast runtime with more compute cores. You are going to internally have more number of compute cores present in your computer, so that the runtime, the execution time of your program gets decreased. You can increase the runtime of your program. That is a major goal of your parallel computing. And larger problem size with more compute nodes. You can increase the size of your problem. When you are implementing parallelism in your program, as long as it can be executed in parallel, the size of your program can increase, and increasing the computational speed. When you implement the concept of parallelism, the speed of your execution of your program also increases, the throughput also increases, and improves the performance of a computer system. Obviously, when the throughput increases, the performance of a computer system also increases, and 2 or more ALUs can work concurrently to increase the throughput. So here, in order to implementing the parallel computing, we are having more than one CPU present, or more than one ALUs present in your computer, so that the parallelism can be achieved and the throughput of your computer system can be achieved. So these are the goals of parallel computing. So if you see here, this is a serial execution environment. If you consider the making a process of a particular recipe, so if you consider chef, we are taking one chef, we consider the chef as a CPU here, and that particular chef, he takes 30 seconds for each and every task. This particular task, it takes 30, this task takes 45 seconds, so 30, 60 and 15. Overall, it takes about 3 minutes to complete the entire recipe for one chef. So he has to do one after another, he cannot do anything in parallel. So after this particular task is completed, then he has to move on to the next task and do it until the entire task is completed. It requires about 3 minutes of the execution time. So the same thing in a parallel execution environment, how it can be executed. So here we have multiple chefs, chef 1 and chef 2, where we consider these as CPUs. There are multiple CPUs present, where each CPU is going to share it. The work is being shared among the 2 chefs. So when this chef is going to work on these 2 tasks, the other chef is going to work on these 2 tasks. So parallelly, whoever completes first, the last task will be done by them. So by doing this, doing this particular execution in parallelly, they are going to save the time. Rather than taking 3 minutes of the execution time in preparing the recipe, it can be done in less than 3 minutes. So this is how a parallel execution environment works. Now how can we achieve this parallelism? We are talking that the parallelism can be implemented, you can execute multiple instructions in parallel, so that the throughput of your system increases. So but how can that be achieved? How the parallelism can be achieved? So the main purpose of a parallel processing environment is to enhance the processing capability of your computer system and increase its throughput. and it can be achieved by having multiple functional units present internally in your hardware. So if you see here, as we already discussed this diagram in case of the parallel processing in unit 4. So the parallelism can be implemented by internally in your hardware by having multiple functional units present in your hardware, so that whenever you have a program, say for example you have a program where you have an instructions called, say you have a multiplication instruction, you have an incrementer instruction, you have a floating point divide instruction. So when you have these 3 types of instructions present in your program, you can give all these 3 instructions parallelly to different functional units that are available. So you have a multiplication unit available, incrementer available, and a floating point divide unit separately available in your hardware. So when you are providing multiple functional units available in your hardware that are capable of executing multiple instructions in your computer, then the parallelism can be achieved. Then you can, rather than taking more amount of time for executing the program, when you are executing multiple instructions in parallel, it takes a less amount of time. So for that you need to duplicate you need to have multiple functional units, or you need to duplicate your resources, and the data has to be distributed among the multiple functional units. So the parallelism can be achieved, and the throughput can be, you can get a throughput in a less amount of time. So the parallel computing is nothing but it is the execution of many operations in a single instance of time, and not only from the hardware point of view, even from the programmer point of view, there are certain things that need to be taken care when you want to implement a parallelism in your system. So the first thing you have to do is the programmer need to identify and expose the potential for parallelism. So when you take an application, the programmers has to identify to which level, which code of your application you require to implement the parallelism, and which code of your application you need to implement the parallelism. So it has to identify the code where the parallelism need to be implemented, and so that particular code has to be executed in parallel. And potential parallelism means that you are certifying that it is safe to conduct the operations in any order as the resources becomes available. When and where the resources are available, you have to issue that particular parallel instructions to be executed in parallel, so that the parallelism can be achieved. And with parallel computing, there is one more additional requirement. These operations must occur at the same time. Parallel in the sense, at the same time you are executing multiple instructions. So that is the thing. So for doing this, you need to have your resources available. You have to leverage your resources to execute these operations simultaneously. So that is the thing that has to be taken care from the programmer's point of view. So if you see this is an example of a parallel computing environment. If you consider the entire problem as a task, it is divided into subtasks and executed by multiple processors in parallel. So the subtask, in each instruction from each subtask will be given as an input to a processor. So multiple instructions at a time will be executed by a processor. So it implements the concept of parallelism among multiple processors that are existing in the system. So whatever we have seen till now about parallel computing, now we will get an idea of what is parallel computing, what has to be done. So with that we will come up with a definition for parallel computing. So parallel computing is nothing but it is a practice of identifying and exposing the parallelism in the algorithms. When you take an application, you need to identify where and where. So obviously when a program is there, you do not require parallelism to be implemented in all the parts of the program. Some instructions you need to be executed in a serial manner, where some instructions need to be executed in a parallel manner. So you need to, the programmer has to identify where and when and where the parallelism has to be implemented. You need to expose the parallelism in your algorithms and express them in your software, implement them in your software, and understanding not only the parallelism has to be identified and implemented. When you are doing this for a large sets of data, you have to take the cost also into account. You should make sure that there is a cost benefit analysis done at the programmer's side. So you understand the cost benefits and limitations of a chosen implication. So this is the overall definition. Parallel computing is a practice of identifying and exposing the parallelism in your algorithms, expressing them in your software, and understanding the cost benefits and limitations of a chosen application. So what are the different types of parallelism that are available? In general, when you implement a parallelism, there are different types of different ways the parallelism can be implemented. There are 4 types basically. One is a bit level parallelism, data level parallelism, instruction level parallelism and task level parallelism. So, coming to a bit level parallelism, it refers to the size of a data the processor can work with. So, if you see a 32-bit processor, take a processor with a 32-bit word size or a data size, then at a time that particular 32-bit word size, it can perform 4 independent 1 byte addition operations. For example, say addition operation takes 8-bit. It will be done in a 8-bit data format. Then you can at a time, based on the size of your processor, which is a 32-bit word size, you can perform 4 independent parallelly, it can execute 4 independent 1 byte addition operations simultaneously. So, this is called as a bit level parallelism. Based on the size of your processor word, you are going to perform parallelism among your instructions. Next, coming to the instruction level parallelism. So, in case of an instruction level parallelism, we are going to program instructions are reordered. So, we are going to basically group the task into set of instructions and multiple instructions are executed in parallel, that is called as a instruction level parallelism. When instruction level parallelism comes into point, we implement the concept of pipelines, where you execute multiple instructions in parallel in the pipeline. So, modern processors include structures as pipelines that allow instruction execution be divided into segments. We know that in instruction level parallelism instruction pipeline, we are dividing the execution of an instruction into multiple segments and they are executed in parallel among multiple instructions. So, this enables different stages of multiple instructions to be executed at the same time. So, this is called as a instruction level parallelism, which is being implemented among multiple instructions that are being executed in a pipeline. Next, coming to a task level parallelism. So, in case of a task level parallelism, we are going to divide or decompose a sequential process or a task into subtasks and all the subtasks are executed in parallel. So, that is called as a task level parallelism. Coming to a data level parallelism, here when you come across the data level parallelism, we have already seen the concept of Flynn's taxonomy in 4th unit, where we come across a taxonomy which is called as a single instruction multiple data stream, which means that the single instruction is being executed on multiple CPUs with different sets of data, right. So, the data level parallelism implements the concept of single instruction multiple data streams. So, the instructions for a single stream operate concurrently on different sets of data. So, that is called as a data level parallelism. So, next coming to the fundamental laws. So, next topic we are going to talk about what are the fundamental laws of parallel computing. So, there are basically in parallel computing we need to modify our application to make use of the resources at a higher extent. So, there are two fundamental laws that are applicable in parallel computing. One is the Amdahl's law and one more thing is Gustafson-Bars's law. So, here in our syllabus we are going to talk only about Amdahl's law, which is a basic fundamental law for parallel computing. So, before going to Amdahl's law, there is a technical term which is used in a fundamental law which is called as a speed up. So, what do you mean by speed up? Speed up is nothing but it is a quantitative measure of the performance which defines the benefit of running a program in parallel. So, basically the speed up is nothing but we are representing the speed up as S of n and represents the number of tasks. So, S can be represented as T of S sequence divided by T of parallel, which is nothing but it is the ratio between the time taken for the system to execute n tasks in a sequential manner divided by the time taken for the system to execute the n task in a parallel manner. So, this speed up gives that how speed is a parallel processor compared to a execution on a serial processing environment. Next is the Amdahl's law, which is a basic fundamental law of parallel computing. So, this Amdahl's law is often used in a parallel computing in order to find out the theoretical speed up when you are using multiple processes. When your program is executed among multiple processes, when it is executing in a parallel computing environment, how can you define the speed up of a parallel computing environment? That is defined by means of an Amdahl's law, and it is named after a computer scientist named Jean Amdahl in 1965. And this Amdahl's law is basically mainly used for a fixed problem size. The size of your problem is fixed. So, it tells that for a given problem size, the speed or speed up does not increase linearly as you increase the number of processes that are going to execute on a that is going to work on the program. So at some point of time the speed up is going to be saturated. We will see it with a diagram. So if you consider this, this is your speed up and this is the number of processes. So for example, say I have 4 functions that need to be, my program contains 4 functions that need to be executed in parallel. So as I have given 4 processes that are going to work, where each processor is going to work on one function. So up to 4, when you increase it from 1, 2, 3, 4 up to 4, as you increase the number of processors, the speed up of your program increases. But after a certain point, no matter how many number of processors you increase, the speed up remains saturated. So after 4, if you give the task, because your problem size is fixed, as you increase the number of processors also, if you make the 4 processors to 10 processors also, the same work of 4 functions is being distributed among the 10 processors. So you cannot get any more amount of speed up. So if you only till some point of time, the speed up will increase, but when it after some point of time it goes to a saturation point. So where you cannot achieve any speed up. So it is calculated by the formula speed up of n is equals to 1 by 1 minus p plus p by n. So if you take 1 as your total work, so s plus p, s means the serial execution plus p stands for the parallel execution. As I already told you, if you take a program, the program contains a serial part and a parallel part. Some amount of instructions, some instructions has to be done only in a serial manner, where some part of your code has to be run in a parallel execution environment. So if you consider s plus p as your total work, this serial part can be represented as 1 minus p. So the serial part of a job is equal to 1 minus parallel part, plus the parallel part is shared among n processors. So p divided by n. So the total speed up can be achieved by 1 by 1 minus p plus p by n. So this is the potential speed up of an algorithm which is given by an Amdahl's law. This is a fundamental law. Next, coming to applications of parallel computing. So when and where the parallel computing is applicable, to what type of applications? Mainly this parallel computing is available where you have large sets of data to work with, like the database applications, data mining applications, as well as your image processing applications where you and real time simulations, graphics and gaming applications. When you come across the different types of gaming applications, this parallel computing works very well, and in case of advanced graphics and augmented and virtual reality applications. These are the different types of parallel computing applications. Next, coming to the advantages of parallel computing. So it's, as we know, we are executing multiple things in parallel. So it is going to save your money as many resources are going to work together. That is a basic advantage. And when you take a large size of nowadays the applications are very big, which deals with lots and lots of data, large sets of data, so which is not possible in a serial environment. So for those type of data, it is impractical to solve large problems on a serial computing environment. So that is one of the basic major advantage of parallel computing. And main advantage is it takes advantage of a non-local resources when the resources are finite. When the system has a limited resources and when we are connected to an internet or a network, it is also going to make use of a non-local resources when parallel computing comes into role. And it makes better use of the hardware. All the hardware will be utilized in a better manner rather than wasting the resources, all the hardware resources. Even though you have multiple functional units present in your hardware, you may not, if you go for a parallel environment, only one hardware unit will be will perform the execution. Only one will be utilized at a time by the CPU. But here, by implementing by giving multiple instructions to multiple hardware units at the same point of time, your hardware resources can be used at the maximum extent. So that is the advantages of parallel computing. Next, the limitations of parallel computing. So the communication and synchronization between the subtask and process is difficult to achieve. When you are executing multiple subtasks or multiple instructions in parallel in a parallel computing environment, you have to make sure that the synchronization is very much important between them when multiple instructions are run in parallel. So the synchronization and communication between them is a major task, and this algorithm should be designed that can handle the parallel mechanism. When you are writing a code in a parallel computing environment, it should be capable of executing parallel instructions in parallel, so that the parallelism can be achieved. And we require more skilled experts to implement that particular, to write the algorithm for the parallel computing environment. It cannot be done by a normal person who can write a code for a serial environment. So it requires some skilled expert, so that parallelism can be implemented on the programs, so that they can achieve a high throughput and improve the performance of your computer system. Next, we are going to talk about the next concept, important concept, which is high performance computing. So, high performance computing is nothing but it is a practice of using parallel data processing to improve the computing performance and perform the complex calculation. Moreover, the high performance computing is implementing the concept of parallel processing environment in order to improve your computing performance as well as to perform complex calculations. It is not used for general calculations, it is mainly used for complex operations or complex calculations. We implement the concept of high performance computing, which implements the concept of parallel computing. So, when we come across high performance computing, we are making use of something which is called as a GPUs. GPU stands for graphic processing units, and these are something like, these are a high capable processing units. So, when we talk about GPUs, we need to have a comparison of what is a CPU and what is the difference between a CPU and a GPU. So, CPU, as we already know, it is called as a brain of your computer, which contains several functional units like your ALU, which is responsible for performing arithmetic operations, as well as a control unit, which is responsible for generating the timing and control signals. When comes to a GPU, the GPU is used to provide the images in games. It is mainly used for high-end applications, mainly it is used in gaming applications mainly, as well as high-end database applications which deals with a large sets of data. We implement the concept of GPUs. And GPU, if you see in terms of a speed of CPU and GPU, GPU is very much faster compared to a CPU speed, and it gives a higher throughput, as well as they are going to handle lots of information. As I told you, they are used in a database applications which deals with the larger data sets. So, GPUs are going to give a high throughput, and the processing and they are going to process lots of information in its thousands of cores quickly in parallel. So, that is how a GPU executes compared to a CPU, and GPU contains more number of ALUs than CPUs. So, this is a diagram which represents you the differences between a CPU and a GPU. So, CPU stands for central processing, whereas GPU stands for graphic processing units. So, CPU needs more memory than GPU, but the GPUs will have less amount of memory, and it contains minute powerful cores, but GPUs contain very weak cores, but you have more and more number of cores compared to your CPUs. And CPUs are suitable only for serial processing environment, whereas GPUs are not suitable for serial processing, they are mainly suitable for parallel processing environment. And it contains 2 or more cores. Maximum, if you see a CPU, which is where we come across a dual core, quadra core, maximum maybe up to 8 cores you can have internally in your CPU. But coming to a GPUs, you can contain hundreds of small cores present internally in your hardware. So, as the number of cores increases in your GPU, the number of parallel processing, the amount of parallel processing also increases, the throughput also increases. So, depending upon the number of core, that many times it can provide the performance compared to a CPU. So, this is a diagram which will clearly explain you the difference between a CPU and a GPU. So, this is your normal CPU. Here we have 4 ALUs, so 4 functional units available, and you have one control unit, one RAM and one cache memory. So, if you see, even though if you have a multiple functional units in your CPU available, there is only one control unit which is responsible. So, for giving your control signals or assigning the job to the ALUs is the main thing of the control unit. So, at a time it can assign a task to only one ALU at a time. So, it is the role of a control unit to assign the task. At a single instance of time, the control unit can assign a task to only one ALU. So, coming to a GPU, graphic processing units, you have multiple ALUs present in your hardware, and each and every these 5 sets of ALUs, they have their own control unit and a cache memory. So if you compare it with your CPU, this is more powerful and more fast compared to the CPU, but because it has its own control unit at a time, since you have 3 units at a time, all the 3 units can start their execution. So because they have their own control unit, a control unit at a time, it can give to one ALU. So all the 3 control units, they can assign the task to 3 ALUs at a time. So they have their own cache memory. So this is how, what is the difference between a CPU and a GPU. So this is the CPU architecture comparison. So as I told you, you have a dual core, quadra core, 8 cores and all. So this is a simple CPU which has a 4 cores. Cores are nothing but a functional units which are present internally in your CPU. And coming to a GPU, so we call it as a multiprocessors. So here we have multiple processors present in your GPU, where each processor internally, if you see each multiprocessor internally, it has a 32 cores present in it, which means it has internally 32 functional units present in it. So overall, if you have 14 multiprocessors, each and every 14 multiprocessors, you have 14 into 32. So at a time, it is capable of performing 14 into 32 simultaneous operations at the same time compared to your CPU. So that's why it is very fast compared to your CPU. And one more thing, a GPU cannot work on its own. It cannot work individually. It has to be used along with a CPU. So it is a combination of CPU and a GPU. If you have a program, the program resides in the main memory of your CPU, and the task of the CPU, and we already know that a program contains a serial part that need to be executed and a parallel part. The instructions that need to be executed in a serial manner, that will be taken by the CPU, whereas the instructions that has to be executed in parallel corresponding to that particular program, they can be executed on a GPU. So it is the task of a CPU to identify the parallel part of your program and assign it to the GPU so that they can be executed in parallel on a GPU hardware. So coming to the GPUs, they are of 2 types. One is an integrated GPUs and other is a dedicated GPUs. So integrated GPUs are nothing but within the same chip of your processor, your GPU resides. So you have your processor chip. So within the same motherboard or your processor chip, the GPU resides, that is called as an integrated GPU. Coming to a dedicated GPU, a separate peripheral, like it acts as a, you have your external hard disk or your mouse which acts as an external device. So like that you have a dedicated GPU which is not a part of your processor. So these are 2 types of GPUs. Next, coming to the potential benefits of parallel computing or high performance computing. What are the benefits? Basically, we have already seen what are the advantages. Now we are talking about the benefits. What is the difference between advantages and benefits is, advantages will tell you about what are the positives of that particular environment, and the benefits are going to tell from the user's point of view how the users are going to benefit out of it. So the parallel computing can reduce your time to the solution. You can achieve the solution in a less amount of time, increase the energy efficiency in your application, and enable you to tackle large problems on the currently existing hardware. So with the existing hardware, you can work out on a large set of data or problems. As your problem size increases, using the existing hardware, you can provide a solutions to the problems. So the main goals of potential benefits are reducing your runtime of your application, performing a larger calculations, decreasing your energy consumption, and reducing the cost. These are the potential benefits. We will see one by one. So the fast runtime with more compute cores. We are telling about you can perform execution of your program in a less amount of time, or you can increase your runtime of your program. You can provide the fastest runtime. So reduction of an application's runtime is often thought to be the primary goal. For any major goal of a parallel computing is you have to reduce your runtime, or increase you have to provide an output in a less amount of time. So the parallel computing can speed up the intensive calculations and multimedia processing and big data operations, whether your application takes days or even weeks to process. So that is one time. The whatever, if you take a more larger applications which takes more number of days or weeks, that can be implemented with a parallel computing or a high performance computing in a less amount of time. And large problem size with more compute nodes. By exposing the parallelism in your application, you can scale up your problem size. You are implementing the concept of parallelism. So as long as your problem size increases, no matter, you can increase your parallelism in your application and implement it, and larger sizes are enabled by great amounts of, as your problem size increases, you are going to have more amount of memory available in your CPU that accommodates the data, and parallel computing can reduce the cost. So as I already told you, when you are implementing the concept of parallel computing or a high performance computing, not only the parallelism or a faster runtime, large problem size should be taken into account. The cost is one of the primary goal or major concern, mainly for a software developers when they are going to execute on an application. So as the size of your application and system grows, you need to perform a cost benefit analysis on the resources available. These are the, so that can be achieved easily by means of a high performance computing or a parallel computing environment.